Hi, Ruth.
Hello.
Um, I'll just hand over to you and I'll see you after. And for you audience members, please keep the questions coming. We're loving them.
Good. Well, great pleasure. And I must say, everything that Sander explained was perfect. So there's a lot of interesting things for talking about microgravity. But today it will be about something else. And you see the question already. We call it planet Earth, but maybe we should call it planet Ocean or planet Water, Terra or Aqua. So I will talk about our beautiful planet. The environment is the theme. And actually, we realized that more and more how vulnerable our planet is. It started actually in 1968 when people went for the first time from the Earth to the moon in 68 and went around it, and they saw something special. They saw Earthrise, this iconic picture taken by Bill Anders, one of the Apollo 8 astronauts. And he said already then, we went to the moon, but we discovered the Earth. We all of a sudden, we realized that we all live on a blue marble, very fragile planet in in a danger environment. I mean, it's empty, it's radiation, it's cold. This is our oasis. We have to do with this planet. Now, if you are in orbit around the planet, you go up, you launch, very exciting, you dock to the space station, and then for more than a half a year, and 204 days in my case, you circle, you orbit the planet 16 times per day. And of course, at 400 kilometers altitude, but the Earth is turning below you. So you go around the planet in 1.5 hours, the Earth turns. So every time you see a new part of the planet below you. So these are the orbits of the station. And if you're flying, say over Aztec, you can see all the way to the middle of Scandinavia and to the south of Spain. So a big part of the planet you see under you. Now we have fantastic windows. Of course, we work very hard, but of course we also have the windows in our free time. Mostly we watch out of the windows, and the cupola is the great place. From there you have a fantastic view on the planet. Sometimes you look out the window and you see the Earth below you. And sometimes you think, where's the Earth? It's above you. It depends on how you look out of the window, because there is no up and down in the weightless conditions of the station. Sometimes you fly along a wall of water. And here we see the Pacific with the Hawaiian Islands here, the big island here on the left bottom. And it's a fantastic planet. Now, there's, of course, a lot of clouds on this planet. And it might be boring, but also there you can see interesting things. Beginning storm, for example, like here, or complete hurricanes. And even from space, the hurricanes look threatening. You don't want to be under there. Beautiful deserts. Here we have Australia, and these red deserts or yellow yellow deserts. Here you see the Nile, the Delta. You see the Sinai. You see the Gulf of Suez, Gulf of Aqaba over there. So interest to see also the sandstorms. You get a lot of sand going here from the Sahara all the way to the Atlantic. And this picture I took over the Brazilian coast, and there you see how the sand is going all the way through to South America over there, ending up here in the Amazon. And here you see the outflow. So the Amazon, beautiful tropical rainforest. Now let's go to islands. Here we see the most beautiful place on the planet, most colorful place on the planet, and these are the Bahamas. On the right you see Florida, on the left you see Cuba, beautiful turquoise waters, and it's fantastic. You already realize from, oh, there's a beautiful place. There's a lot of life going on out down there. You see all the sand formations underwater, and actually when I saw that, I thought I have to go diving there one day, because it's such a beautiful place, even from space. Here we have Venezuela, and you see here for the Dutch lookers, it is Aruba and Curacao and Bonaire on the right top there. And here the Indonesian islands of Bali, Lombok and Sumbawa, and going over here in Flores on the right, in the center Komodo, where the famous Komodo varan is living, and the underwater world is fantastic over there. So it's a beautiful planet, but like I said, should we call it planet Aqua? Because 70% of our planet is covered with water. You see interesting things in the water. You see some shading from ocean currents near the islands there, and you see wave patterns in the oceans. Very interesting, huge waves, and you wonder if you see it from space if this is a tsunami or something, or maybe you don't even notice it when you're there on a ship. But huge waves you can see in the oceans. Also ice. This is Kamchatka, and you see the spirals there, and this is a lot of sea ice. So a lot of things to see in the water, and even the Pacific, which is, well, a huge part, even from space, it's a big piece of water. You can see some jewels there. And now and then you see these beautiful islands. This is Aitutaki, one of the Cook Islands, for example. Beautiful places. These are the Maldives. And you realize that in these colorful places, there must be a lot of interesting things going on the water as well. So these are mostly volcanoes which sink, and then the coral reefs exist, ending up in these beautiful lagoons. So atolls are very nice from space, and a paradise for life over there, of course. Now at night, the sun goes down 16 times per day, 16 times we see sunrise, 16 times sunset, and you see nice reflection on the water. And in the center we have here the Netherlands. It's hard to see, but here it's a bit better. On the left you see Ireland, and there we have Scotland and England, Wales. This is the North Sea, and here we have the Netherlands, and here we have Belgium. And you see reflection on the water, and also contrails of planes. Now then you go over the Terminator, and then the Earth at night, and you see this. It's very double side because it's beautiful, all the city lights. The orange part is Belgium there, and on top we see the Netherlands. But you also realize there's a lot of people on this planet, a lot of people, and they mostly live where water is. For example, here you see nicely, we fly over the Sahara, and now you see this golden snake, which is the Nile River. Everybody lives in the water. Over there you see all the towns on the Red Sea, the diving resorts, for example, the Red Sea, Sinai, and here on the left Cairo, and here totally left is Cyprus. And now at night, here from another point of view, the Middle East, the Red Sea on the left there, and you also see all these lights in the ocean. This is in the South China Sea, and all these lights are fishing ships. You see light blue dots, you see purple dots, you see green dots. These are the real colors. Fishing ships, enormous amounts of fishing ships. And then you realize that has a big impact on nature, of course. There's a lot of stress on our planet because of all the activities of humans in the forests, but also on the oceans. It's not only in the South China Sea. Here you also see huge fleets of fishing ships, fishing vessels, and this is near the coast of Argentina. You see on the left, you see the Falkland Islands here, and so it's a visualization of the pressure that we humans have on the water. So a lot of people on this planet, and they all want energy, they all want transport, they all want sweet water, etc. And that, of course, we get into conflict with the environment. Now we have great satellites, and ESA is building fantastic satellites for Earth observation. And with those, we use it to watch our planet, for the climate, for the oceans, for the atmosphere, etc. And for all kinds of reasons, to follow deforestation, but also air pollution. Like this device, the Tropomi, is on one of the ESA Sentinel satellites. It watches all the air pollution on our planet, for example, in a lot of detail. Here we see Germany, France, Belgium, and the Netherlands, a lot of detail. But also for the oceans, this can be important. This is, for example, the Strait of Gibraltar. On top you see Gibraltar, and you see the ships. But with Tropomi, you can measure this kind of thing. So you see the air pollution, because these big ships are big polluters as well. You can clearly measure the polluting of the atmosphere and the effect on the environment, of course. And then also in the oceans itself. On the right, you see ESA pictures of oil pollution. So we use it also to look at the oceans. So we can see a lot on space. The salt content of the Mediterranean, for example, or the turbidity of the river Elbe here in Germany. And of course, also the temperatures. Ocean temperatures we can measure from space. Temperatures have a big effect on coral reefs. They don't like hotter water. They don't like that sea level is rising and that the oceans are getting more acids. And these kind of things we measure with satellites. Also the melting of the ice, of course. It has a big effect if the ice on the North Pole is melting, big effect on shipping routes, which has a big effect on the environment, the flora and fauna in the polar regions, for example. Now, all this data from all these European satellites go down to Frascati, ESA facility, and there it's analyzed, and every government institutions can use this data for their activities. So we have a beautiful planet, and it's the only one we have. We cannot just go to another planet. Maybe some astronauts can hop around on Mars, but that's it. If we have problems on this planet, we have to solve it on this planet. A beautiful planet. The others poisonous, too hot or too cold, or no oxygen, etc. The only place we have is planet Earth. It's a fantastic planet. Maybe we could call it planet Aqua or ocean or water. And of course, the question is, what can ESA do to protect this planet, but also what we can do, or how do we deal with the things that are underwater? And for that, we, of course, my duo speaker here, Peter, I think it's your turn to talk about what ESA can do for the underwater world.
Okay, thank you, André. I'll take this chair. Okay, good afternoon, everybody. So that was just amazing. I'm not even going to try to match the images of André, but I will try to do is to complement some of his images. And I'm going to talk about the effect of marine litter on the environment and how ESA, how are we trying to help. So this is actually matching what André just talked about. He's just looking in his free time through one of the windows. And in this case, he's flying above Indonesia. So everybody is probably jealous and says, okay, you know, I wish I was there. I wish I could look out of the International Space Station and actually see this image. But on the other hand, this is what André is missing. You know, he sees it, the beauty from the Earth from top, from space. But if you continue, if you go diving, actually the beauty continues underwater. So he's missing this beautiful, fantastic colored coral reefs. Yeah. This is another image. You actually have seen the image in the presentation of André. This is the Sinai desert. And underwater, it's actually the same story a little bit, if you want. Beautiful reefs. In this case, you know, there are even these really little nice orange-colored anthias that are just swimming against the current. So it's fantastic. Beautiful to see. It doesn't always need to be soft coral, because it can also be hard coral. In this case, you see actually the cliffs of the Sinai desert. And what you also can observe is that the reefs, the really healthy reefs, continue up to the shoreline. So you don't even have to go deep. The Red Sea, I think André already mentioned it. There is quite a lot of fishing, quite a lot of ship traffic. And yes, of course, we start seeing the impact of mankind. So you see wrecks. Sometimes the wrecks are perfectly sunk for divers, so as tourism, and then they're perfectly cleaned and they don't harm the environment. But of course, some really sink because of bad weather. And in this case, it's a victim of war. It's quite a well-known wreck that you see here. Still nice to dive, but yes, it shouldn't be there. Then a bit less harmful is this image. You can actually see it from space. This is wastewater and surface runoff. And just to explain what I mean with those terms, wastewater in very simple terms is that you flush the toilet and it goes directly into the water. There are rules nowadays, you know, that try to prevent that. So the problem is getting less and less. It still exists in certain countries, but it's getting less and less. And it's not only people, but it's also, for example, the ships, the cruise ships that used to have the problem, but it's less and less. Surface runoff, and I need to point out, let's say, all these gray dots that you see here on the satellite images. Whoops, that's not supposed to happen. Those are actually buildings, houses. Everybody wants to live close to the coast and wants to enjoy, you know, the ocean and even seeing the sunset, you know, in the evening. I can't blame them, because I would probably feel the same way. The problem by building all these houses, all these buildings very close to the coast, is that they remove trees and bushes. And by doing that, you actually prevent, or actually you don't stop the soil from eroding into the rivers and then going into the ocean. And I'm going to try to point out here again, if I have my mouse, this is a river, and you see a river here as well. So when it rains, the soil goes into the river and then goes into the ocean. And this is a bit of a problem, because if the sand goes on top of the reefs actually suffocate. They can't breathe anymore, if you want. And then, as opposite to what I have shown before, these beautiful reefs, the only thing I see is just barren soil and just a sandy bottom. Thanks to the satellite images, we're completely aware that this is happening, and we're starting to work on it. And this is an example. The picture that you see here is what they call a nursery for coral reefs. It's just a few simple plastic tubes, and on the plastic tubes you have small pieces of coral that you hope start growing, and when you have a decent size, you actually replant them where the reef originally was. Yeah, so at least we're addressing the issue. Thanks to satellite images, we're fully aware. So this is an example of something that you can see from space. But now I'm going to an example of what we're doing to the marine environment, which you can't clearly see from space, at least not with the naked eye. So if André would be here with the International Space Station, just flying over this region, looking out of the window, he would probably think that this is an amazing day, sun shining, and this is correct, it's fantastic topside. However, what we encountered when we went diving was this. So this poor turtle was caught in a ghost fishing net, a fishing net that is abandoned, and you see the amount of plastic that it also caught, and of course the turtle was strapped inside the net. So we did manage to free this turtle, and it was still very healthy. It was trying to bite us whenever he could. So it was very healthy, and it disappeared. So we felt really good in the evening that we were able to rescue a turtle. So André passes this region again, another day. He looks down and says, okay, it's again a really nice, beautiful sunny day. And it's true, you see a few scattered clouds, but that's it, another sunny day. And believe it or not, we actually encountered another turtle caught in another fishing net. You see again the amount of plastic, that is dragging around. And this poor animal was probably caught a bit longer than the previous one. It was a bit weakened. We still managed to set it free, and it was swimming away. So at least we gave it a fighting chance to survive. Another day. So here you start seeing a few clouds on the oceans, and we can confirm that it was a bit windy, and there were a few clouds when we were diving another day. This is what we encountered. So this is a problem, of course, as well. Here you see a medusa, a jellyfish, if you want, is hidden in between plastic. And I have to admit, even for us, for human beings, the color is the same as the plastic that is floating on the surface. You could even say that the shape is kind of the same, if you want. Now, this is the primary food source for many marine animals, for example, the turtles that we just shown before. So when sometimes by mistake, they eat the plastic. And if there is too much plastic eaten by the animals, they sometimes actually even die. So this is a serious problem. Another image that we were sadly enough able to take was this one. And here I don't have to explain, we were obviously too late to rescue the turtle. So we really need to do something about the litter in the environment, in the oceans. Okay, what can we do? I mean, it's nice to just figure out, okay, there is a problem, but what can we do? So this is a graphic. On the left of the graphic, it's basically visualizing what the issue is, and I hope that I've been able to show that for the marine life, it's clearly a problem. The ecosystem, I think I've addressed. Human health, if the particles become smaller and smaller, so big chunks of plastic very often degrade into smaller particles, and if the smaller particles are small enough, the fish eat them, and if you eat the fish, you basically get the plastic inside yourself. Tourism is an obvious one as well. If there is plenty of plastic rubbish on the beaches, they become less attractive for tourists to go to, and the tourism suffers. On the right, this is, let's say, our hope. This is what we should do. So the top one is satellites. Are we able to figure out the concentration of plastic in the oceans? And it could also be the earth, the oceans and on land. The big advantage of satellites, and André already addressed that in his talk, is that we have a global view. Yeah, we're not bound by political borders, economic borders. We can just look globally. Now, once we know where the plastic is, and like I said, it can still be on land, the second step that we could do is, if you know what it is, where does it go to? Yeah, and that's the middle plot on the right. So for that, we would need a model of the ocean currents, the waves, how are the waves behaving, and ultimately how the wind is behaving. If you have that data, the ultimate goal is to make a model for politicians to see if they start taking countermeasures, what effect does it have? So over the year, they can monitor basically what is happening. Are we really solving the problem or not? And I'm going to touch upon every of these images briefly. Just, at the plastic, just some numbers. And I'm always very careful if I start giving numbers, because if you look at different literature, you'll probably find different numbers. So what I did is I just said estimated, but even if it's 4 or 5, it's still an enormous amount. So what I wrote down here is 8 to 9 million tons of plastic litter per year going into the oceans. That's just phenomenal amount. And what surprised me really a lot when I started working on is that of only 1% of this plastic litter, we actually know what is happening to it. So that for me was a big surprise. Then we have models, we have different models, but the models do not necessarily agree with each other. So we would really need to provide the scientists with data so that they can improve the accuracy of their models so that they at least converge. And again, I'm going to stress, space-based solutions are able to give a global view. So wherever on Earth you have a problem, we should be able to address it. Okay, so now we know more or less where the plastic is. Now we need to predict where it goes to. And what I'm trying to do with this animation is to show that it's not going to be an easy task. So I'm going to start the animation. This is actually January this year. And here you see very complex patterns of the ocean currents. Yeah, so if you think that the ocean currents will simply follow a general trend and that they will follow the coastline, that is absolutely not true. Actually, here you see a really nice example of a current flowing orthogonal to the main stream. You see all kinds of eddies, circular movements. So this is a very complex pattern. So it's going to be really difficult to address that properly. Same thing for the wave height. And before I play this video, I'm going to point out that the red, the color red, is 9 meters, or for our American listeners, let's say 27, 30 feet. Yeah. So these are quite some waves. It was New Year's Day, 1st of January 2020. You see that the UK probably was complaining there was bad weather and that they couldn't go out for a nice walk during New Year's Day. But let's play the video. Yeah, so you see clearly the UK. You can also see that definitely Canada was hit by bad weather. So they also had waves 8, 9 meters high. Japan, 4 or 5 meters of waves. Australia was kind of safe. And then you see, yeah, just there, a spot of high waves again in front of the coast of Africa. So what we're facing is a very complex pattern of ocean currents. We have waves going up to, let's say, 10 meters, and the blue is basically 0. So there's a lot of variability in the wave height. And if I add on top the wind, you can imagine that it's going to be a complex problem. But if we have this data, who's going to be enthusiastic about this? Well, first of all, the scientists, because the data would allow them to study the concentrations and the transport dynamics of the ocean plastics. Yeah. And like I said before, most of the basic fundamental questions of plastics at the moment don't really have an answer. So we really need to address those. The modelers, yeah, okay, I already said, the models don't agree. Let's give them data, the really scientific data so that they can improve the accuracy of their models. Policymakers, just to make it simple, the politicians, if they set policies or regulations, we need to be able, with scientific data, to show if their policies or regulations make sense. Do they have an effect? So let's take the emotion, let's take the feeling out of the discussion. Let's provide scientific data. And then, of course, nowadays we have ocean cleaners. Well, ocean cleaners can only work effectively if we tell them where the plastic is. They need to go to a place where the plastic is to be able to clean it. Another issue there as well is, if they start cleaning it up, does it make sense? We can look at the same spot for every week, every month, a couple of times a year. But at least we're able to show if the problem is getting less or if it stays the same. So we can try to determine the effectiveness of their strategies. Here, I think I'm super proud that I'm able to present this slide because the top management of ESA recognized the issue, and they opened up what we call a campaign. Let's say it's a budget line where you can submit proposals to on remote sensing of marine litter. And we have been able to kick off 27 projects addressing remote sensing of marine litter. So I'm not going to say that all of these are going to be successful, but even if several of them can, make advances, at least we are starting to solve the problem. So we have 27 academia, research institutes, industries working together on a common goal of addressing this issue. Then I don't want to end with, all gloom and doom. The underwater world is still phenomenal. It's still really nice. We're still able to dive with fantastic shoal of fish. The corals are still beautiful in certain places. I mean, you see here that, people are living basically on the edge of the coral reef. If you do it in a sustainable way, there should not be a problem. So I definitely want to say, it's not too late, but let's work on addressing the problem. Yeah, let's conserve our underwater world. Yes, it is a big challenge, and hopefully I have been able to explain that a little bit. It's a very complex problem. It's not a simple current that goes from left to right. It's, the waves do very strange things. The wind is a factor as well. And plastic, I showed the image with the naked eye, it's maybe not visible. So it is a big challenge, but at least, we're applying our resources and innovative technologies to support global efforts to solve this problem. And with that, I'm going to thank you for listening and open it up for questions. And I'm going to stop sharing.
Hi, Peter.
Hi.
Hi, André. We had some really good feedback already in the chat. People loved it. One question is, where are you?
Okay. I think I'll take that question. So we're actually in the Hertz room, and I'm going to move the camera a little bit. So the antenna that you see there behind André is actually an antenna. The technology that we use for making that antenna is also used for the next generation of Earth observation satellites to study exactly the issues that we're discussing. So this is for Earth observation satellites, at least the technology that is used in that antenna. And the room that we're in is the antenna measurement room, where we measure the performance of antennas like this.
Amazing. I quite enjoyed this question about how deep you can look into the sea with your Earth observation satellites. Can you observe the deep sea as well?
No, so the most of the frequencies that we use can only see the top surface, maybe 1 or 2 centimeters below, but you can't really go penetrate into the water surface. But it doesn't mean that you can't see the effect on the top surface of what is below. So that's some of the ideas that is being generated, in these activities that I discussed about. There are some people that think, if there is enough plastic material in the ocean, it actually starts dampening the waves.
Oh.
Yeah, so you see a different effect of the waves localized. Let's say the phenomena are different. So we can't go down in depth if you want, but maybe we can see the effect of what is below the water surface.
I also have a question for André.
Okay, then I'll do it like this.
My son dreams of being an astronaut so much he started trying to learn Russian. He's 8. What is a good subject to study to make his dream become a reality?
Well, you have to realize that the astronauts come from all kinds of backgrounds. They are scientists, they are medical doctors, they are engineers, pilots, all kinds of different things. So the most important thing is that you should go in a direction that you like. If you have a passion, you're probably good in it as well. So that's the most important thing. Do something you like in that field, of course. And to learn Russian is it's handy, but if not, then they teach you. They teach you how to fly, they teach you how to dive, they teach you how to talk Russian. So a lot of things you don't have to know already before. So there's some basic requirements for astronauts. Of course, you have to be in good health. You don't have to be a top athlete. You don't have time for that either. So, but you need a good health in a normal condition. You need to have your study background with 3 years of experience and age between, say, 27 and 37. These were the requirements in my time, but they will not change very much. And then, of course, you need the right passport of a country that participates in ESA. And that's an important thing. So then you should try. So he has to promise me at least try. You know, if you don't try, it's certainly not going to happen. So try it and follow your passion.
Wonderful. Thank you so much. We are slowly getting towards wrapping up. So thank you so much for this talk. I really, really enjoyed it. And I feel like I learned a lot. And we got some really good feedback in the chat. Bye-bye, Peter. Bye, André. Have a good rest of the day.